The other factor here, well, how small do you need it? Less than epsilon over 5, right? So if x is close enough to both happen, and f of x squared minus 4 equals f of x minus 2, and x plus 2 is less than epsilon over 5 times 5. Okay. Now, okay, translation then. Or rather, okay, so if x is close enough to 2, what delta do you need for this thing? How close should x be to 2 for that?
Within 1.
Within 1, right? Okay, so the idea is that if f of x minus 2 is less than 1, we've got it. Now x is less than 5. Oh, wait a second. Now he gave us a particular tolerance, right? 1, right? All right, sorry. I'm carried away here. If x of x minus 2, okay, and then how close do we need for this statement to work? Clearly just within. Okay, so what delta do we want here? Let delta equal 1/5, right? Say f of x minus 2 is less than this delta, right? And then we have all this stuff, right? And then, so finally we do this, right? Okay, so we remember how to do this, right? Good? It's what we learned in the wire factory, right? Seems like a totally different problem, right? But it's just the same methods, right? Okay. Now what if he says, okay, well now, okay, that's wonderful, fantastic, okay. And then the next question, in that case it must be so that if x is close enough to 2 and this is less than 0.1. Can you prove that? Right? And then you say, sure, I can do that. I'm just going to change all the ones here to the 0.1. Right? And then, so anyhow, and then you just spend the next 15 minutes just giving you various tolerances, right? And you just deal with them all the same way. And then finally he says, okay, in that case, okay, so finally, nobody ever did this at the wire company to you, okay? He's going to say, okay, suppose epsilon were arbitrary. Now, you've even prepared for arbitrary epsilon, but nobody actually gave you an arbitrary epsilon. That wouldn't happen. The customer's always giving you a specific tolerance, right? All right, so then, but he says, okay, in fact, whatever epsilon, it must be so that x is close enough to 2 and f said for minus 4 is less than epsilon, right? And can you prove that? Of course, he said, sure, well, just change all these things, right? All right. Well then. Okay, in that case, only thing difference is what? I would need to let delta equal the The minimum of it's going to be 1 on epsilon. The minimum of 2. Okay, so now, and then he says, well, wonderful. You know, that's exactly that. Now you must understand that what you've done is actually prove this, right? Because you told me that this is the case, and in fact, it's true that no matter what standard I tried to use to measure how close x squared was to 4, however demanding I was in that standard, still this statement was true, right? Okay? So therefore, that's a proof. Now the only thing is, and then he just leaves you, he says, congratulations, okay, now just think about how you handle this function, right? What difference does that make? Okay, well before we do that, let's just write down the definition of limit. Okay. Say Mr. Epsilon were to prescribe a tolerance. All right? And then what can we say? So, in other words, what do I define? The limit at x goes to a of f of x equals what? Means what? Okay. Say you were to prescribe a tolerance. Then what?
X is close enough to A. But not even to it.
Oh. Then
Function fx is close to
f of x is what?
close to L. How close? Very close. Tolerant, very close.
Tolerant. Okay. Now I've got to emphasize that it can be any tolerance he gives me. I've got to be prepared for anything, right? So that's the new ingredient. I'm going to write here whatever it is, whatever the tolerance is, then this happens, right? Okay, let's try to phrase that now over here. What do we say? Okay, so that's a good one, okay?